Welcome to our lesson on antiderivatives and integration. Today we'll learn what antiderivatives are, how to find them, and see various examples that will help you master this essential calculus concept. Let's start with the fundamental concept. What is an antiderivative? An antiderivative of a function f of x is a function capital F of x whose derivative equals the original function f of x. In mathematical notation, we write capital F prime of x equals f of x. Finding an antiderivative is called integration, and we represent the general antiderivative using the indefinite integral symbol, like this. The integral of f of x dx equals capital F of x plus c. This c represents an arbitrary constant that we add because differentiation eliminates constants, so when we reverse the process, we need to account for all possible constants. Now, let's explore the basic rules of integration that will help us find antiderivatives efficiently. The first rule is the constant rule. The integral of a constant equals ax plus c. For example, the integral of 5 dx equals 5x plus c. Next is the power rule. The integral of x raised to the power n dx equals x raised to the power n plus 1 divided by n plus 1 plus c. This works for any power except negative 1. For example, the integral of x cubed dx equals x to the fourth power divided by 4 plus c. The third rule is the constant multiple rule. The integral of a times f of x dx equals a times the integral of f of x dx. For example, the integral of 7x squared dx equals 7 times the integral of x squared dx, which equals 7 times x cubed over 3 plus c. Finally, we have the sum and difference rule. The integral of f of x plus or minus g of x dx equals the integral of f of x dx plus or minus the integral of g of x dx. For instance, the integral of x squared plus 3x dx equals the integral of x squared dx plus the integral of 3x dx, which equals x cubed over 3 plus 3x squared over 2 plus c. Now, let's look at some common indefinite integrals that appear frequently in calculus. First, the integral of e to the x dx equals e to the x plus c. The integral of sine of x dx equals negative cosine of x plus c. The integral of cosine of x dx equals sine of x plus c. The integral of 1 over x dx equals the natural logarithm of the absolute value of x plus c. And the integral of a to the x dx equals a to the x divided by the natural logarithm of plus c, where is greater than 0 and not equal to 1. Memorizing these common integrals will save you time when solving more complex problems. Let's work through some examples to see these rules in action. Example 1. Find the integral of the expression 3x squared minus 4x plus 5 dx. Step 1. We'll use the sum and difference rule to split this into separate integrals. The integral of 3x squared minus 4x plus 5 dx equals the integral of 3x squared dx minus the integral of 4x dx plus the integral of 5 dx. Step 2. Now we'll apply the constant multiple rule and the appropriate integration formulas. For the first term, we have 3 times the integral of x squared dx, which equals 3 times x, cubed over 3, which simplifies to x cubed. For the second term, we have negative 4 times the integral of x dx, which equals negative 4 times x squared over 2, which simplifies to negative 2x squared. For the third term, we have 5 times the integral of dx, which equals 5x. Step 3. Combining all terms, our final answer is x cubed minus 2x squared plus 5x plus c. Example 2. Find the integral of x raised to the power of negative 1/2 dx. Step 1. We'll use the power rule. Here, n equals negative 1/2, which is not equal to negative 1, so the power rule applies. Step 2. Using the power rule formula, we get the integral of x to the negative 1/2 dx equals x to the power of negative 1/2 plus 1 divided by negative 1/2 plus 1 plus c. Step 3. Simplifying. This equals x to the power of 1/2 divided by 1/2 plus c, which equals 2 times the square root of x plus c. Here's a visual representation of the function and its antiderivative. Notice how the slope of the antiderivative at each point matches the value of the original function. Example 3. Find the integral of 2e raised to the power of 3x dx. For this problem, we'll use a technique called substitution, which is useful when we have a composite function. Step 1. Let u equal 3x, so du equals 3 dx, which means dx equals du divided by 3. Step 2. Rewrite the integral in terms of u. the integral of 2e to the 3x dx equals 2 times the integral of e to the u times du over 3. This simplifies to 2/3 times the integral of e to the u du. Step 3. Integrate using the standard formula for the integral of e to the u, 2/3 times e to the u plus c. Step 4. Substitute back to get our final answer, 2/3 times e to the 3x plus c. It's always important to check your work when finding antiderivatives. The way to do this is to differentiate your answer and confirm that you get back the original function. Let's verify our result from example 3. We found that the integral of 2e to the 3x dx equals 2/3 e to the 3x plus c. Now we differentiate. The derivative of 2/3 e to the 3x plus c equals 2/3 times 3 times e to the 3x, which equals 2e to the 3x. This matches our original integrand, confirming that our antiderivative is correct. Let's summarize what we've learned about antiderivatives and integration. 1. An antiderivative of a function f of x is a function capital F of x whose derivative equals f of x. 2. We express the general antiderivative as the indefinite integral. The integral of f of x dx equals capital F of x plus c. 3. We use various rules to find antiderivatives, including the constant rule, power rule, constant multiple rule, and sum/difference rule. 4. For more complex functions, we often use substitution to simplify the integration. 5. Always check your work by differentiating your answer to confirm you get back the original function. With practice, you'll become more confident in finding antiderivatives and applying integration techniques to solve various calculus problems. Thank you for watching.